We're looking at the C2 2016 May paper, question 9, parts D and E. So part D, it's asking us to use calculus to find the minimum value of P, giving your answer to the nearest metre. So the minimum value of P, we know that's going to happen when the differential dp dx equals 0. And we know that it's a minimum when the double differential is greater than 0. So now that we've got that statement, we know that we first have to find dp by dx. So let's first write dp in a form that's differentiable. So we've got this power minus 1, bring the x up. So we can differentiate that quite easily, and we're going to bring the power down. So bring this minus 1 down and minus 1 from the power. This here, well, this is just a constant, it's just a number. It could be 5, it could be 10. If it was 10x and you wanted to differentiate 10x, you'd just get 10. Likewise, because this is just a constant, when we differentiate this whole thing, we are just left with the constant. So we can bring that x down onto the bottom, and then we're now going to set dp by dx equal to 0. That's when we've got a turning point. Set it equal to 0, bring that first term over to the left, so take this over. We're going to times both sides by x squared, so we're going to take this x over here and take this thing under the 1000. We can now take the square root of that thing, remembering our plus or minus, always when you take the inverse of a square, and we're going to get plus or minus 16.63. Now, in the question at the very beginning, we were told that x is between 10 and 25. They always tell you this for a reason, and it's normally because you can ignore one of the solutions. So we're going to ignore the negative 16.63. So our final answer for x is 16.63. What's important is that you don't stop there and think I've got my answer. It's asking you to find the minimum value of p. So we're going to go back. At x equals 17, what does p equal? And we're going to look at part C for our equation of p. And we'll just substitute in, that should say 16.63. I'll just leave it as 6. So 16.63. Substitute that into the p equation. And we're going to have 120.24. However, it's asking to the nearest metre, so we're just going to round down to 120 metres. And that's our final answer, our p value, not our x value.